Welcome everybody to today's edition of INNOQ's Technology Lunch. Today our topic is blockchain. We know from past experience that this is a topic that leads to a lot of discussion. In that spirit, I will keep my introduction very, very short. I'll hand over to my esteemed colleague Lars Hupel, who will give us an intro, a very quick one, to blockchain. And then we'll talk about some of the use cases and some of the things that are sort of anti-use cases. So that's going to be our topic today. We'll talk about when to use the blockchain, when to avoid to use it, and we're very much looking forward to having some discussion with you. For that discussion, please use the YouTube channel to send us your questions. I'll hand over to Lars now, and after his presentation, I will start introducing your questions, ask some of my own, and hopefully we'll have an interesting lunch together. Enjoy.
Hello, everyone. Thanks for tuning in, and thanks, Stefan, for the introduction. As you already mentioned, my talk today is going to be mostly about use cases of blockchain, but also anti-use cases. But also, I would like to, of course, give a quick introduction to people who are listening who might not be fully aware of what blockchain means and how we define it. And also, I would like to give you tools or an idea how to assess various blockchain technologies, because there's a lot of stuff out there. But I'll keep that brief, and then, of course, I will go further to some examples and anti-examples. All right, so let's start. Let's dive deep right in. What is blockchain even? And while talking with many people about blockchain technologies and at conferences, it's always the case that some terminology isn't quite clear. So I would like to start out with giving a very short overview of terminology as I would define it. So probably the most famous blockchain implementation is Bitcoin. And Bitcoin is a cryptocurrency, which means that you manage some kind of money on the blockchain. Now, this talk is not about money and speculating with Bitcoin or buying or selling Bitcoin. So if you're expecting to learn how to make money with Bitcoin, this is not the right talk for you. But I hope you will stay on for the rest of it. Now, cryptocurrencies are basically a special case of so-called digital tokens. And digital tokens can be many other things. So a digital token can also be used to manage other kinds of things, other kinds of real-world things. For example, you could assign tokens to products and then manage the flow of these products, for example, in the supply chain using those tokens. And those tokens are very frequently managed by so-called smart contracts. And smart contracts we define to be pieces of code that can be executed on a blockchain. And most of the time, those smart contracts, in particular in public blockchains, are written in a special programming language, but there are also smart contracts that can be implemented, for example, in Java. Now, all of that runs, of course, on some form of blockchain. And a blockchain, of course, is an append-only data structure that is distributed among many computers. But it could also be, it's also defined to be a special case of the so-called distributed ledger. And the difference between that is that in the blockchain, transactions are grouped together in blocks. So you can have, for example, a block that contains 100 transactions, and those blocks are distributed. But in principle, that's not strictly speaking necessary. You can also just consider transactions one by one, and then we would talk of a distributed ledger. And a ledger is something that is a very old notion from accounting. It dates many centuries back. A ledger is basically just a book where you put in transactions that have happened and the kind of assets that have been moved. And the distributed ledger is basically just a ledger that is distributed across many computers. Or speaking formally, a distributed ledger is an append-only store of transactions which is distributed across many machines. That's really all there is to it. And based on that, we define a blockchain that it is a special case of distributed ledger that is structured as blocks, and these blocks contain ordered sets of transactions. And typically, we would use some kind of cryptography to secure the links of these blocks, right? Because you would want to avoid manipulation. You don't want all transactions to be manipulated, and that's really the main use case of blockchains, to have this kind of append-only storage, and all transactions can never be changed or deleted. But I'm not going to dive into the cryptography topic here. This is an image I took from a paper from the Department of Homeland Security in the US. And they have kind of boiled down the essence of blockchain technology. So there are many different blockchains out there, but all of them have kind of 4 core attributes. So the first one is trustless consensus, which means that many different parties that may not trust each other can come together and form a consensus of things that have happened. For example, they can agree on the fact that 5 transactions happened between A and B. Second, it's highly redundant, which means that it is very unlikely that the system can crash, because you have so many different copies of the same data, basically distributed across multiple machines. The third thing is you have an immutable record, which I've already mentioned. It is very unlikely that you are able to manipulate all transactions without anyone noticing, right? So you could try to change something in history, but other people, the rest of the network, will notice that you have done a modification and can say, well, this is not what happened. And for people who are developers who are tuning in and listening, you may notice from Git, right? So if you use a Git repository and push something to GitHub, for example, it's very likely that you will notice if something has happened with the history. You will get merge conflict, for example. And then there's a fourth point, which is not present in all different blockchain technologies. It's only present in some, which is role-based access control. And in public networks like Bitcoin or Ethereum, there's not really any access control going on. Everyone who has a computer and an internet connection can participate in the network and can also try to mine new blocks and make transactions. But there's also another side, which is kind of enterprise blockchains, which are more of a limited network where only a particular set of participants are allowed to make transactions or even listen for transactions. And we can separate this across 2 different axes. So we can distinguish between read access and basically write access. And read access, we can have public blockchains and private blockchains. Public, of course, like Bitcoin, anyone can participate. In private, you need some kind of key or token to be allowed in. And also, we can look at the write privileges, like who is allowed to create transactions, who's allowed to create blocks. And then we have permissionless, which means that anyone can do that, like in Bitcoin, or permissioned, where you need some kind of privileges. And I have here a slide on various different blockchain implementations, which you may have heard about before. So Bitcoin and Ethereum are in this public and permissionless space. Then there is a space which is public and permissioned. Those are kind of, some of them are experimental, others are trying to solve some scalability issues of Bitcoin, for example. But in this talk, I'm not going to look at the public blockchains. In this talk, I'm going to focus more about enterprise use cases, which are private and permissioned. So the main players here are Corda and Fabric. And you can look at their websites to figure out what the underlying technology is. But for this talk, all you need to know is that it's kind of a really distributed database that you can install across various organizations, and then you can make transactions between these different organizations. That's the basic idea. All right, let's move on to an assessment chapter. Do I need a blockchain? And if so, which blockchain do I need? Now, as many of you are undoubtedly aware, is that the problem with many blockchain technologies is that there is a whole lot of marketing hype around it. So when you go to a website of some blockchain technology, you will find probably some white papers. And these white papers may or may not look like an academic paper. So there's a formal description, you may have proofs in there, you have fancy formulas and symbols, all that stuff going on. But then you have to decide, is this actually a real thing? Like, is this scientifically sound and accepted? Or is it maybe just marketing? So there's dozens of startups who have created some particular blockchains for a particular use case. and many of them just don't survive. They just collect some money and then they're gone. And maybe that's fraudulent, or maybe their science just wasn't good. And this is a big problem. So if you're in the situation to decide, I would recommend looking at the big players that already have some momentum in the market, because those are the players who have already proved that their technology is sound. And I would probably err on the side of safety there. Now, let's talk about some of the criteria that you can use to assess your personal use case. Let's say you have a particular use case for some kind of business use case, and you want to figure out if blockchain technology would be right for you. The first thing you would need to look at would be decentralization. So only if you have a decentralized system, then a blockchain makes sense. For example, if you are a single company and everything happens inside of this company, and you have like a trusted IT department or something like that, that you trust to not be malicious and manipulate it and stuff, then there's no need to use a blockchain, because the key idea is that you have a decentralized network, you have multiple different participants, and they have to agree on transactions. But if you just have a single organization, like a big company, for example, there's really no point in having a company private blockchain, because you are just missing the decentralization aspect. And this is really key, because many people will try to sell you a blockchain for your own private purposes, but that really doesn't make sense. You could as well just use a database. And in software architecture, there's also a pattern that's called event sourcing. And event sourcing satisfies many of the properties that are desired, like having an append-only storage. At the same time, event sourcing can be deployed without a blockchain. So if you have a private use case, then maybe just use event sourcing and don't bother with a blockchain. It may not be the right idea. The second criterion you should look at is history. And with history, I mean a history of transactions. If you have a use case where you just need to look at the current state of things, like you have, for example, you have an inventory, and this inventory comprises a bunch of products, and like you have 5 products A, you have 10 products B, and so on. And if you trust that all of this information is correct because you operate the warehouse, for example, and you trust that no one has tampered with it, and you trust that it's complete, you don't need a blockchain. You just put that into any kind of database, like a Postgres database or whatever. It's just an SQL database. On the other hand, if you really need some kind of history, possibly an append-only storage, then it might be a proper use case for a blockchain. For example, if you have a warehouse and many different companies bring items into that warehouse, and you need to be able to track and trace who brought that stuff in there and who's taking out stuff from this warehouse, then you may be very interested in the history and figure out what was going on at a particular point in time. And it is then necessary to have some kind of append-only storage. This would be a good use case for blockchains. Now, the next criterion is access. And with access, of course, I mean access control, who's allowed to read data, who's allowed to write data. And in public networks like in blockchain, like in Bitcoin, access control is kind of present, because in order to participate in the network, you need to invest money in terms of energy, right? If you want to create new Bitcoin, you need to be running some kind of software that tries out a bunch of hashes and maybe succeed at some point. And this is used to avoid spamming the network, right? So Bitcoin prevents spamming from happening like that. And in enterprise use cases, that's hardly necessary, because you have kind of a predefined set of participants. And you usually have some form of legal framework that determines who is allowed to join and what are the procedures for people to join or for companies to join. So in that case, you don't really need that kind of proof of work or proof of energy, because you can just say, well, here's your public-private key pair. With that, you can participate in networking. You're allowed to make transactions. And if you have one of these participants who's then spamming the network, for example, you have legal recourse. You could sue them, for example. You could sue them for malicious use of the network. And that's really, there's no difference between blockchains and traditional networks like that, because in many cases there are these legal frameworks, and you can sue people if they just tamper with your if they tamper with your network. Furthermore, it's kind of a similar thing if we're talking about identity, right? So if you have an enterprise use case, you would probably know all your participants. And based on some kind of legal contracts, they are usually only allowed to do what it says in the contract. Also, you would probably need some kind of trusted arbitrator, right? So if you have a contract with another company, then somebody needs to decide in case of disputes what the resolution for that is. And in many cases, that's just the courts of the country, or it could be some kind of other form of arbitration. The next criterion would be processes. There are some blockchain implementations that support smart contracts, and there are other blockchain implementations that do not support smart contracts. And this is an important thing to decide. If you have some kind of code that you need to execute with transactions, for example, let's say somebody puts a product into a warehouse and then some code needs to trigger and needs to update some other stuff, that could be a use case for a smart contract. And the advantage of smart contracts is that all the people that are participating in the network can agree on what algorithm is being run. On the other hand, if you have kind of a trusted IT department and everybody agrees on the code that's deployed there, then you probably don't need smart contracts. You can just run it on regular machines. On the other hand, if you need this traceability of computation, not just of transaction, but also of computation in your network, then smart contracts are a really nice idea to do that, because you can even go as far back as, like, you can say, 3 years ago, some transaction happened and some code was executed. What code was executed at that point? And that may be interesting for compliance purposes. With smart contracts, that's trivial, because you have the entire history of smart contracts and computation stored in the blockchain. However, if you have a traditional like cloud deployment of whatever, it's very hard to figure out what code precisely ran 3 years ago. I would even go as far as saying that's impossible. Like who knows what precise code was deployed at this point in time? But with smart contracts, it's trivial, because every time you have a transaction, you can just look at the blockchain, at the state of the blockchain at this point, and see what code was executed. The final criterion is privacy. And privacy, we are going into some really strict legal territory here. In many use cases, you are not allowed to use a public blockchain because it would leak data of your customers, for example, to the public, and that's just not good. So if someone tells you you should be putting your customer data on the Ethereum blockchain, that's probably not a very good idea. Much data that's in an enterprise is actually supposed to be private, and maybe even just visible to a subset of users. And in that case, you need to take encryption into account. But again, I would err on the side of safety here and would recommend using a private blockchain or a blockchain that's somehow access controlled in order to avoid any kind of data leakage. And what I've shown you is not just my opinion, but it's also the opinion of the National Institute of Standards and Technology in the US. They have this handy flowchart, and it's basically a condensed version of what I just told you. They have there are some small differences, but basically they also tell you in many cases just consider a database, and they even tell you consider email or spreadsheet, right? So sometimes a low-tech solution would also be good. You don't need to deploy a 10-node blockchain across 3 different continents if an email could do it, right? Of course. All right. So let's move on to the next part, which is how do I implement a blockchain? So I would like to show you the different the different concepts you would need to look at in order to figure out how to transform your business use case into some kind of blockchain-based implementation. And of course, this is from an architectural point of view. I'm not going to tell you how to program a smart contract in Java based on the Fabric implementation. That would be far too much content for this technology lunch. But I would like to give you an idea of some kind of architectural patterns that you would find in common implementations, and maybe you can see some kind of similarities to your domain that you're working with day to day. There are a bunch of different entities that are involved in modeling a blockchain, but the most central point is really the transactional aspect. So when you look at your domain, you need to identify what are the transactions in this domain. And transactions can also be called events, right? If you're using, if you have done an event storming workshop, or if you're using domain-driven design, then you will be very familiar with events. And events are kind of like transactions, right? You have a particular set of operations that happen at the same time and need to be happening together. You cannot split the transaction into smaller transactions. And a transaction in a blockchain use case could be, for example, a money transfer, but it could also be an asset transfer of some kind of physical goods. And the aspects you need to take into account would be who is allowed to initiate the transaction. So is it anyone? Is it your customers? Is it your business partners? Who is it? Who will validate the transaction? So who will make sure that the transaction was actually okay to proceed? Is that just yourself, or is it other people that need to agree on that? Revising transactions, how does that work? Is it possible to have like a countering transaction? So let's say you have a transaction that was wrong, you need to undo it somehow. That's very important. Then you need to figure out the identity. So how do people identify against the system? Do they do that with technical means or with other means? You need to identify what assets you have in the system or in your domain. So an asset would be, for example, a product, one particular physical object, for example. And of course, you need to figure out how to connect this physical object to your blockchain, right? Do you put a barcode on it, for example, or do you have any kind of other form of attaching a particular identity to an object? And then the other two things would be a distribution and storage. Now, this is more from a technical point of view, not from a domain point of view. Distribution would be, for example, what computers are, or how many computers are storing the blockchain. And storage then would mean figuring out the actual low-level implementation of this. Do your transactions, for example, contain big binary data? Or like, do you have gigabytes of transaction data? Then you would need a different kind of storage mechanism as if your transactions are just kilobytes. Okay, so that's just from an architectural point of view, and that would conclude the part where I tell you some abstract architectural ideas about blockchain. Now we are going to dive into the examples and some use cases. Where could I use blockchains and where shouldn't I? And I have prepared a few examples for you, and I will talk about them, what they mean, and what our opinion is. Should you use a blockchain for this or not? And of course, this is up for discussion. So if you have questions, if you come to different conclusions, please put that into the YouTube chat, and Stefan will read those questions to me at the end. So let's start. First example would be nonprofits or charities. Now, there are hundreds and thousands of nonprofits and charities around the world. And what they do is they take donations from people or organizations. Then they manage these donations, so there's some kind of management overhead, and then they choose who receives the money, right? So you could, for example, apply for a project and saying, I am doing these things for the community, I would like to get some money, and then they will distribute, these charities will distribute the donation money to these projects and that they deem are worthwhile. Of course, nonprofits and charities, what they want is they want to avoid a high administrative overhead, right? So if only 60% of your donation money actually arrives where it is needed, that would be bad, right? So they would like to reduce this overhead to a very slim amount. But at the same time, they need to be extremely transparent, right? They need to explain every step they take because they have kind of a responsibility towards their donors. There are some certifications on this from some organizations that look at the accounting of these charities and tell you this is good, this is not good. And personally, my opinion is that blockchains could really improve the situation here because you would kind of have a standardized notion of tracking these donations and expenses. And this could really help in reducing the administrative overhead. Now, this is a classic example for a decentralized operation or decentralized system because there are so many non-profit organizations and there are so many possible donors, right? So there's not necessarily a whole lot of trust between those. So you could imagine, for example, a donor sending some money to a non-profit, and then the non-profit would need to file some transactions on the blockchain saying, okay, we have selected this organization that receives the money, right? So you could, as a donor, you could say, well, I can just look at the blockchain and then I will figure out who actually received the money. And then if I'm happy with that, that's fine. I can give more money. If I'm not happy with it, I could go to another charity where I deem this a better use of my money, basically. And from our point of view, blockchains could really improve this because right now it would be very hard for an individual donor to figure out where the money went to. You would need to read some kind of reports, and all of these are just aggregated accounts. So you could say, well, maybe 1% of my money went there and the other 10% went there. With blockchain, you could have a full traceability of this. So from my point of view, from our point of view, we would say this is a good use case for blockchains. Of course, the devil's in the details. You would need to figure out that privacy is somehow preserved. So you would need to be able to assign some kind of anonymous identity to donors. So one particular donor can still identify their contribution, but it should not be possible for me, for example, to figure out how much money someone else donated to a particular charity. So, of course, there's some implementation details to figure out there, which is why this is not a complete open and shut case, but in principle, a blockchain could be an improvement for this use case. Okay, let's move on. Second use case would be merchants. And I apologize, this is an extremely German perspective on this problem, because in Germany, there is a very strong cash payment culture, right? So in other countries, you just pay everything by credit card. And of course, if you pay by credit card, everything is traceable. It's very hard to have tax fraud and stuff. But in Germany, many people just will pay by cash. And there are even many shops that don't accept credit cards. They will just take cash. And cash is by definition very hard to trace. So for customers, that's good, right? There's no bank that will know where to spend money on, but it's also bad for tax authorities because there's a very large amount of money that just cannot be taxed because there's no, the government cannot trace it. Now, there's legislation on this that the cash registers need to have some trustworthy accounting records, but they can be manipulated, right? It's a technological solution that's under control of the merchant, and all of these things are difficult to implement. And blockchain is basically, in our point of view, not a good solution to fix this because if you go to a merchant and you give the money, they can still choose to not enter this transaction into the blockchain or into their cash register or whatever, right? They could just like write you a piece of paper by hand, for example, and that's actually very common in restaurants that you would get just some handwritten piece of information. So even if there is some kind of shop blockchain, no one stops the merchants from just not entering their transactions, or maybe they just enter 50% of the transactions, and the rest they just don't. So in our point of view, it would be extremely hard to enforce any kind of blockchain solution there. So we don't think it's the worthwhile use case. Next point in our list would be property. And property can be construed in a very general way, but here in this example, let's talk specifically about used cars. And sales of used cars are fraught with problems because for you as the buyer, you would need to know some essential information like the mileage, previous accidents, any modifications, and things like that. And they may not be obvious, right? You inspect the car, but you may not know if all of that information is accurate, right? So somebody could have manipulated the mileage. Now that's very hard with modern cars, but it is still possible, and it still happens. And there's like a cottage industry of people manipulating these mileages. But also tracking of sales is important for legal reasons. For example, if you're talking about import and export of cars. And of course, all of these things also apply to other kinds of regulated property, such as real estate. You have kind of similar problems there. And here, in our opinion, this is like the perfect use case for blockchains, because in Germany, you need to give your cars to an inspection every 2 years. And you could just mandate that all of these car repair shops and the official checking agencies would need to participate in a blockchain and just like put all the different things that happen to the car over its lifetime in there. And then you as a buyer could look at the identification number of the vehicle and figure out, oh, this is what happened to that car. So from our point of view, this is the perfect use case. And again, this is very decentralized because you have so many different people that are involved with cars in general. You have car repair shops, you have buyers, you have sellers, and there's just many different parties. And none of them trust each other. In particular, me as a buyer, I have no reason to trust that the seller is telling me the accurate information. So in a blockchain, I could circumvent the problem. I could just look at the history of all the transactions that happened to this car. Of course, again, there wasn't the details. There would need to be some legal framework to compel the car repair shops to participate in this. But because these car inspections are very heavily regulated by the government, this should be a problem that can be solved. Okay, next one is kind of the idea of innovation and patents. The idea of a patent is that you prove the knowledge of an idea, and in a patent you need to also reveal that idea. But if you file a patent, then the patent office and the state will help you protect this patent. And they will also check if it's novel, and then you can sue people who steal it. And many people have suggested that blockchain would be a good idea, because you could, for example, you could write down your idea in a PDF. Then you could take the hash of that PDF and then submit it to some kind of blockchain, and you can prove later on, I've already had knowledge of this. You were stealing this from me. However, the current patent system is heavily misused. There's a term that's called patent trolls, which are people or organizations that just buy up old patents from people, from other organizations, and then use it for the sole purpose of suing other people. And this patent system has been heavily criticized in that respect, because in order to prove that somebody stole your idea, you need a lot of money, right? You need to go through all the courts to prove that someone actually stole this from you. And this is in many situations that's extremely hard, and it's also very hard across international borders, right? Let's say you have registered a patent in European Union, and someone else is stealing this patent or is using your intellectual property, then it's going to be extremely hard to track them down. Or maybe just in the US, you need to find a lawyer in the US and pay them tons of money to litigate this in the US. So this is extremely hard, and the initial idea of a patent protecting the small guy who has ideas and corporations are stealing this, and then they can sue them or whatever. This is really hard to enforce because because of the way this enforcement works through the courts. So from our point of view, blockchain really does not help a lot. It helps you nothing if you can prove beyond reasonable doubt that you've had this idea. But if you need so much money to enforce that proof, then there's no help in using blockchain. Okay, finally, The last use case that I would like to talk about is in education. Our company INNOQ, we are a member of an organization called ISAKB, and this is an entity that provides software architecture education. In particular, they define a curriculum. So there's like a bunch of different modules. You have a foundation level, advanced level, and so on. But the organization itself does not actually offer the education. So they only specify the curriculum. The training is actually provided by multiple different companies. And also the examination are provided by different companies. And in fact, you have rules like a company that's offering training may not also offer examination to avoid conflict of interest. And the certificates are interchangeable. Now, in the current implementation, how this works is that when you take an examination or when you take a class, you will obtain a piece of paper and it says, Lars Hupel has successfully taken this class on whatever. And then you can take all of these together, stable them together, say, I have this certification now. But it's very hard to track these different certificates across different organizations. And this is actually the perfect use case of a blockchain. You have multiple different entities. So you have the decentralization aspect. You have kind of a history aspect. You need to figure out if a particular student has taken all the necessary classes. And of course, you don't want the students to manipulate them. That's it. You want to be able to tell them, well, you have actually taken this class or you haven't, right? So no tampering. And yeah, this is a prime use case. And you also have a particular known set of people that can participate and issue certificates, but you have a potentially unbounded number of students that could work with this blockchain, but they only need to read. They don't necessarily have to write to this blockchain. So this, in our opinion, is another perfect example for blockchains. Now, this is all I got from a content point of view. I have a brief shameless plug because we actually offer such a training on a topic called distributed consensus, distributed consensus, our title for a short title for blockchain and various related technologies. And if you use this voucher code, you can actually get 15% off. And I'm sure we will link to this in the YouTube chat. And of course, also, if you want to figure out if blockchain is the right thing for you and want to talk with someone who has looked at various use cases and has analyzed this in many ways, then you can also talk to us. We will offer you some help to figure out if blockchain is right for you and what blockchain would be right for you. And yeah, that's all I got. Thanks for listening, and I'm happy to answer your questions now.
Okay, thanks very much, Lars. We do have a number of questions in the YouTube chat. I'll just pick and choose from them, and we can have a brief discussion about those. I think one of them is kind of funny. It's actually asking, why has blockchain become such an object of ridicule? Something that I experience quite a bit when I talk about this. Why is it seems to be used as kind of a joke, right? If you want to make fun of somebody, you say, well, yeah, or you could use a blockchain and everybody laughs. What's your take on it? You have spent quite some time with it. Do you think it is a serious thing? Does it have only very, very few cases? And what's the reason it has become this this obvious?
I think the main problem is that many fervent proponents of blockchain basically suggest that it will change the entire world and you can use it for everything, right? If you particularly talk with Bitcoin people, they will tell you classical money is useless and it will crash in a year, and then we'll all be running around scrambling for means to payment, and Bitcoin is like the Lord and Savior of everything. And of course, this is ridiculous. The problem occurs because there's so much hype about blockchain, and many people just have a poor understanding of this. There's many people, many companies who will try to establish some kind of useless solutions that are looking for a problem. There are outright malicious participants, because any new industry where you can get a lot of money, where you can earn a lot of money, is like a gold rush, right? So there's a lot of people who want to participate in any way or another and maybe even fraudulently. And in particular, in the cryptocurrency business, there's a lot of fraudulent companies that try to circumvent government regulation and so on. Having said all that, in the past few years, the technology has matured quite a bit. So there's this island of kind of enterprise-grade blockchain technologies that have a particularly narrow set of use cases. I mean, I've told you there are some use cases where they're just not useful at all. And I think it would be good if the conversation about blockchain could be just focusing on these kinds of things. And maybe let's just ignore the Bitcoin fanboys. I don't know. Maybe let's just ignore them for a bit. They can do their own thing. But if we're talking about like actually implementing some kind of business domains, let's not focus on Bitcoin, right? Let's focus on these kinds of enterprise technologies. And I think the ridicule is met because these two areas are often intermixed, right? If you talk about blockchain, many people first think of Bitcoin, right? Hardly anyone thinks of Fabric and Corda and decentralized ledgers and stuff like that. So I would like to shift this conversation more into that region and maybe ignore all the hype around. That.
I would like to add something to that from my own point of view, which is that even within the Bitcoin community, there is a percentage of people who are outright toxic, but there are also some very reasonable people, right? I mean, Bitcoin is sort of a reasonable use case for blockchain technology, but it has some very, very disgusting people who are there, which makes it not the most welcoming community to basically anybody. And that is really sad because there are some very smart, very nice people who want to do really useful things with that stuff. So I think even within that community, that what you just said is true. There are some people who are just ruining the reputation of this thing, but that doesn't mean the technology itself is somehow broken or more broken than what you can assess by looking at it. I mean, everything has its use cases and its lack of use cases, obviously. Okay, well, stepping outside of my questioning role here, which I think is something I will continue to do. The next thing is, there's a question of further reading on implementing blockchains. I think we'll add something to the YouTube chat on that. I always recommend Andreas Antonopoulos' books. Do you have any favorite that you would recommend?
I mean, I have an academic background, so I really like the blockchain book from Springer. We can link to that in the chat as well. And this is a kind of a tour de force around enterprise architecture, and you will see all the different patterns explained in there, like when would you need an oracle and all of these different things. I have actually quoted from them in this talk. I have a bunch of definitions I got from them. And they also mention a bunch of actual implementations. So it's not just purely academic, but you will be able to see some things that can be applied to the real world. Let me just find the slide where I cite them, so you can see the authors and the name. So it's Architecture for Blockchain Applications. That's what the book is called. That's my favorite, but you need to a bunch of time to go through the book. It's really dense and academic.
Okay. Next question is, would you consider patient's health data a good use case for a blockchain?
That's a question I get a lot. I would say any kind of public blockchain that encompasses the public, so that people can look up their own health data. I would probably be against using a blockchain because it is just too easy to get it wrong, right? If you have a data leak, that's catastrophic, right? If any kind of health data is spilled into the public without the consent of the people who are affected, that's a death sentence, right? The project is dead. It's utterly catastrophic. If you have a more controlled environment, then it would probably be worth investigating. Like if you have some kind of network between different hospitals, maybe that could be useful, or specialized use cases. But in general, like a public health system, let's say it ticks a lot of the boxes of when blockchain makes sense, but health data is super critical. And people have, for example, argued that you should be putting corona test results on the blockchain. And I don't think the the conversation in society has finished yet on this. Like how public or how protected do we want to have our digital health data? And the same concerns I have about classical architectures as well, right? So this is the same problem if you would just put health data into a Postgres database, because it's just very easy to get wrong. So I'm not sure we are there yet to consider this, right? So there's some other problems to figure out first.
Yeah, I would completely agree with that, and maybe add that it might be feasible if you add a second layer of security, like end-to-end encryption of some kind, where you encrypt the data and then put the encrypted data on the blockchain. But that should really be something that you consider, because at least in Germany, I'm sure that's probably true in all of the EU. This is actually not something that you should ever take lightly, because you can actually go to jail for making mistakes with that kind of data, right? And rightly so, I think.
Same with voting. Many people have argued to put voting on the blockchain, and
very bad. Yeah.
Absolutely not. Absolutely not.
Yes. So maybe related to that very closely, what about GDPR compliance, especially the right to erasure, which seems sort of to be in conflict with the immutability of the blockchain?
Yes, excellent point. It is true, there are some caveats if you have data that is protected by GDPR, but there are also strategies to solve this. And it's kind of the same strategies that also apply to event sourcing, right? Even in classical architectures, you have this problem. How do you delete user data if you have some kind of immutable storage? And or for example, if you have backups, right? And the usual trick, well, it's not really a trick. It's the usual strategy is you look very precisely at what kind of data you have to retain and what data you may have to delete. In some industries, there's actually data that must not be deleted, that has to be kept record. For example, in banks, you can't just tell your bank, please delete all of my records. It's impossible. But there's also some domains where you may have to delete some piece of data. And the idea basically is that you encrypt all of this data with a user-specific key. And if the user demands that the data is deleted, you just discard that key. Right? That's the same way how you dispose of old hard disks, right? You would store all the data in an encrypted way, and you can discard it by just discarding the key, and you will not be able to read the data again. So basically what it means is you will have some kind of garbage in your event log that is technically still there, but you're not able to access it. And this is actually a common thing, right? This is not new, so to speak. This is also something you have to do in event sourcing. Kind of sort of still having the data, but also invalidating it in a way that you can never access it. And to the best of my understanding, and also literature that I read, this is considered to be GDPR compliant, right? Because you have made the data inaccessible, which is just as good as deleting it. There's actually an interesting article, or a bunch of articles on the Heise page. So if you go to Heise, it's German speaking, and you search for GDPR and blockchain, there's a nice article that explains a lot of more aspects, because there's not just the right to be forgotten, there's a bunch of other aspects in GDPR as well that may be in contrast to blockchain, but all of these problems can be solved.
Mm-hmm. Okay, maybe let's move to the car example. So one question was, let's take that example. That seems to be like a common service that would be useful to everybody there, but who would pay for its development and operations?
I mean, the only chance you get there is if this is somehow government involved, right? So the government regulates how, the government has laws that demand every car has to be checked every 2 years. Or if there's particular kinds of accidents, then these accidents need to be registered. And this is really the only way to get people on board, and you just need to, the government needs to take money and like give it to someone who develops this. Another alternative, which is kind of similar, is if the checking agencies like the TÜV would pay for this, and they would say, well, every time the TÜV looks at a car, then they will put that into the blockchain. But of course, you need some kind of a nationwide entity to get on board, right? It's not possible that, or it will not be feasible if a bunch of buyers and sellers come together to develop this blockchain, because you also need to compel people to use it. So yeah, I think the only way to make this happen is by public development, essentially. Interesting.
I would add to that. I think there is a second option, which would be that collaboration of entities, instead of founding a common entity like a joint venture or something, they would decide to collaborate in this way, and then simply find a way to share the extra revenue or the savings, whatever it is, they make among the people who participate. So your incentive to participate in the whole thing would be to provide some service, either operation of the blockchain itself, or some extra like auditing or security service or onboarding or help or Q&A, whatever, as part of the overall collaboration. And then that would sort of be the incentive for people, for institutions to participate in the whole thing. And it would be sort of a collaborative effort, as opposed to founding a company that would do that centrally. Now, that again is, I think, an interesting discussion to always have. Maybe founding a company that does this centrally using boring old database technology is the better option. That is an entirely possible outcome of the whole thing. So every time you come up with a blockchain solution, you need to consider whether something else might be actually a better solution than this one. And sometimes the centralized solution only has advantages, and you should definitely go with that. So maybe we're doing a bad job advocating blockchain use cases here, but I think it's key that you really consider whether you need it, because it's not a technology that comes without cost.
Yeah, of course. And I would like to add one more point, because you mentioned incentives. Of course, it is better to, if you want someone to use something, right? It's of course always better to give them incentive than to compel them by law, right, or by force, right? I think in the car use case, the incentive could be monetary savings. But I think they are very hard to explain on an individual level, right? You have a buyer and a seller. How do you explain to them that using a blockchain will save them money, right? It's more of a global scale effect. And there are other use cases where the money savings are much more obvious on an individual level, right? For if you track some goods, for example, and this is just faster if it's distributed, whatever. In this kind of use case for cars, I'm not entirely sure if you can do this with incentivation. But in general, I agree. If you have incentives, then use them and people will use your stuff. It's easier than if you have to compel them by law.
Okay. Here's another candidate for a potential use case, which is the expensive notary services. Do you think that is a good blockchain use case?
Yes, of course, depending on what kind of stuff you are doing at the notary. So in particular in Germany, it's extremely annoying if you want to sell real estate or buy real estate. There are tons of steps involved in the notary, and you need to do multiple. For example, if you buy a house on a mortgage, there's like at least 3 different steps involved with getting the bank on like the accounting books and whatever. It's extremely complicated. It takes a long time. And of course, all of that could be potentially automated with smart contracts, because many of these contracts are actually fairly standard, right? So you don't necessarily pay the notary to create a completely unique contract, at least not in 90% of the cases. But in most cases, just a template that they instantiate, and then they charge for their service because, of course, it takes them time. But many of that stuff is the same all the time, and could just be automated away. Interesting enough. This is also a nicely decentralized problem, because at least in Germany, selling or managing real estate is done by the municipalities, right? So you have, I'm not sure how many municipalities there are in Germany, thousands and thousands of them. And all of them have slightly different processes to some extent. And there's no central registry of land, right? You have no deed register for the entirety of Germany. So like every municipality has its own storage, and this could be something that could be very, very simplified using a blockchain. Of course, one would need to think how far you want to automate this, right? Do you want to say everything is automated, or do you say, well, you still have some kind of manual input processes there? But I think this could speed up a lot of processes as well. As for other things that a notary does, I mean, notary is basically a neutral entity that you trust to execute contracts. And this is basically how smart contracts are also defined. You execute some code, you do some things, and then many people agree on the correct execution of these contracts, right? So a notary is just a person you trust. But in a smart contract, you get this trust because every participant can run the code for themselves and see if they agree on the output. So I don't think notaries are useless, because they still provide valuable services. But I think many of the services they provide could actually be accelerated or more automated by using smart contracts.
Mm-hmm. Yeah, I also had an observation a while ago that I found interesting in that particular context, which is that this is already decentralized at multiple levels. One that you mentioned, right? That there are so many municipalities that all have their own local real estate register, but there's also many notaries, and there is also for every contract many copies of that particular thing. So if you want to prove that you bought a house, you have a copy of that contract at home, and you have a copy of the contract at the registry, and you have one at the bank, and you have one at the buyer and one at the seller. So you have multiple copies of the same thing, which is what gives you a lot of trust that this stuff will not be meddled with. If your local municipality ran a piece of software that they bought from somebody that had the digital registry and that was all, then I would not have a lot of trust in that never being hacked, right? Because it's an interesting hard target. People could attack that. And it would have to be operated securely and safely by my local municipality. Now, it's a modern one, a pretty good one, but still they're not typically information security professionals that I would expect to be able to handle that sort of stuff. So putting that into a more into something that has more trust by other means seems like something that is not a bad idea. Interesting use case.
Yeah, one more thing about this. This is also interesting because the privacy constraints are much lower than for other domains, because in principle, buying and selling land is a public transaction, right? Everybody can like get this information, they just have to pay for this. But you have, and it's also like you don't have the right to erase that. Like I cannot go there and say, well, please forget that I bought this piece of land. So the privacy implications are much, much smaller, which makes this an even better use case.
Mm-hmm. Okay. Very good. So we've got another question from somebody who woke up as a cockroach this morning, I think. Sorry, stupid joke. How about the costs if you run those use cases at scale? I mean, scaling is obviously a very important thing here, and most of the existing blockchains, especially the ones that do proof of work, are very well known for being extremely wasteful of resources, of energy, compared to the scalability they achieve with this thing.
Yes, of course, I cannot recommend you to run Bitcoin, try to run Bitcoin or Ethereum at scale, at least not the public proof of work things, because the basic idea with them is that they don't scale that much, because if they would scale so much, they would be susceptible to spamming attacks, and you don't want that. Now, running private blockchains is an entirely different matter, because you're not constrained by these kind of proof of work systems. You can do other kinds of things. Still, scalability is an issue, and as far as I know, the current best systems scale up to about tens of thousands of transactions per second. So you have like 10 to the 5 transactions per second. If you have many more transactions than this, even the private blockchains are problematic at this point. There's tons of research going on into increasing this, increasing the scale. For example, the Fabric blockchain, they internally use Kafka and Zookeeper for establishing consensus. And there's research going on into how they can remove this kind of bottleneck and improve scalability even further than that. There are other blockchains that have even lower scalability than that, so they don't even manage 10 to the 5 per second. And yes, this is something you have to take into account, and definitely something you need to benchmark before you run this, because some blockchain implementations support smart contracts, and they need to run these smart contracts a bunch of times, which of course makes things slower than if you have no smart contracts and just like have a ledger of like some kilobytes of transactions. Of course, that will be much faster. So I'm afraid the answer is it depends. The current best numbers, I think, 10 to the 5 per second. But there's a lot of innovation going on in this space, so this might improve significantly in the future.
Okay. So with that, let's wrap up. Thanks for staying with us this long. If you stayed with us this long, it was very fascinating to listen to you, Lars. Thanks a lot for your time. Thanks to our listeners and viewers. If you like this, please like this video, subscribe to the channel. I always wanted to say that once I like. Okay, so enjoy the rest of your day. Thanks for being with us, and hopefully see you some other week. Bye-bye.
Bye.